All right, let's dive into lesson number 13. Now, the first thing I want to point out, I hope you noticed in the module for today, we are actually going to skip activity number 1. This activity talks about some of the items that we've actually skipped in this unit. So we're just going to skip past this introductory activity and jump right into activity number 2. Siblings in the house. It says, here is a table that shows the number of siblings of 10 students in Tyler's class. Okay, so one student has one sibling, they're the only child, 2 other siblings, 1 sibling. Oh, this was a big family with 7 siblings, etc., etc. Whoa, that's an even bigger family. 10 siblings, that's a lot of siblings. Awesome. Represent the data shown in the table with a dot plot. So we're going to review how to make a dot plot today. All right, so the first thing we need to do to make this dot plot is, of course, make our horizontal axis. I got to leave room for my numbers and my label here, but I should have room here for what I need. All right, there's my axis. My data varies from 0 to 10, right? 0 is the smallest value and 10 is the biggest value. So I've got to make that fit on here. So 0, let's see. 1, 2, 3, 4, 5. I'm going to have plenty of room. 6, 7, 8, 9, 10. I actually made it longer than I needed it to be, but that's okay. All right, there's my horizontal axis, and I didn't leave room for my label, so I'm going to put it over here on the side. This is number of siblings. Down here is my label for my axis. All right, here we go. We need to do some dots now. Our first dot is at 1. And then 0. And I like crossing them out as I go so that I know which ones I've done. Next dot is at 2. I should probably make these dots a little bit bigger here so that we can see them really well. Next dot is at 1, so I'm going to stack that one. And then a dot at 7. Another dot at 0, a dot at 2, another dot at 2, another dot at 0, a dot at 1, and a dot clear up here at 10. Okay, there's our dot plot. Just to be sure, we had 10 students, 10 data values, so we should have 10 dots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we know we have all of our dots on there. So we are done now with number 1. Number 2, based on your dot plot, estimate the center of the data without making any calculations. So we don't actually have to calculate the mean. We are just simply estimating the center or the mean of this data. What is the estimate of the typical number of siblings of each of these 6th grade students? Mark the location of that number on your dot plot. So, like we learned yesterday, we need to kind of estimate where we think the mean will be and then locate that on our dot plot. Now, we have a big clump of dots over here, and then we got some dots kind of hanging out over here. We got some big families over here, right? But I'm really tempted to say that the mean or the center of our data is going to be right around 1 sibling. Maybe between 1 and 2 siblings, it might be kind of a tie, right? But I'm thinking, let's put our triangle right here at 1. That's going to be my estimate anyway. Do you agree with me on that? So I'm going to say the mean is about, because this is an estimate, right? 1. Okay? And that's sibling. Okay? Brother or sister. Now, in number 3, here's where it asks us to actually calculate the mean. Okay? So let's do the actual math. I'm going to take these numbers, of course, from our data set, and we need to add them all together. So 1 plus 0 plus 2 plus 1 plus 7 plus 0 plus 2 plus 0 plus 1 plus 10. Double check that I have all 10 numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I do. And then I'm going to divide by how many there are, which is 10. Okay? Now, let's add these up. I think I can do these in my head. 10, 11, still 11. 12, 13, still 13. Plus 7 is 20. 21, 22, 23, still 23, 24. So 24 on top divided by 10. I know a shortcut for dividing by tens, right? If I divide by 10, that just moves my decimal place once. So this is 2.4. Okay. So my median then, or my mean is 2.4. Well, that's kind of a weird, this is siblings, right? So it's kind of weird that we have a decimal, but that's okay. So so we found the mean. We showed our reasoning. Let's just label this. There's our mean. Because I think we're going to actually have some questions to answer about this. Okay. In fact, I think it tells us to mark this on our... I was going to say, I thought it had us mark it on the dot plot. Let's go ahead and mark that on the dot plot. We'll see how it compares. So 2.4 is almost 2.5, right? So I'm just going to mark that triangle right there. Okay? Let's take a look at what this next question asks us. Number 4. It says, how does the mean compare to the value that you marked on the dot plot as a typical number of siblings? For example, they want you to use phrases like a little larger, a lot larger, exactly the same, a little smaller, a lot smaller, etc. So let's look at this. It's definitely not exactly the same. We thought it was going to be 1, and it's actually 2.4, right? So is that it's bigger for sure. Is it a lot larger? Or a little larger or a lot larger? I'm thinking it's just a little larger. Between 1 and 2.4 is a little bit. So I'm going to say it's a little bit larger. Right? Do you think the mean summarizes the data set well? So do you think 2.4 is a good center for this data? Well, I thought if I had thought that in the beginning, I would have said it in the beginning, right? But I thought it was going to be clear down here. So I don't think I don't think that's very balanced. Do you think that's balanced? I don't think that's very balanced over there. So I'm going to say no on this. The data doesn't look balanced. Remember yesterday when we talked about that idea of the mean being a balancing point? It doesn't really seem to be a balancing point on this one. So maybe there's a better way of finding a center that would be a better balancing point. Guess what, ladies and gentlemen? There is, and we're going to learn that today, okay? Here's our optional challenge problem for those of you who would like to do that. And now we're going to move into this activity number 13 where we're going to find a better middle, right, for this data. And this is really kind of cool that they give us another way to find this middle because like we just discovered, the mean sometimes isn't the best middle, the best center, the best balancing point of our data set. Okay. Now, unfortunately, in activity number 3 today, there was a class activity where we were going to get up and out of our seats and do a bunch of stuff with some index cards, as it says. But of course, we're not all together, so we can't do this activity. And I'm really sad about that because this is a really fun activity. But I do want to walk you through what we would have done because it helps us answer question number 2. Okay, so what you would have done, you would have taken your index card and would have written your first and last name on there. And then you would have written a number on there, which is the number of letters in your first and last name. So let's say your name was Abraham Lincoln. If I know how to spell Lincoln. Okay. So let's count up those letters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay? You would have put a 14 on your card. And every single kid in the class would have done the exact same thing. Okay? And then the next thing I would have had to do is, with your card in your hand, stand up and get yourself on one side of the room, or the front of the room. I don't know. Wherever we had room. Okay? And then I would have asked you to put yourselves in order by those numbers. Okay? Now, if you think about how that would have worked out, do you think there would be more kids in the class that had your exact same number? Yeah, I think there would have been, right? I bet you there's a couple people that have 14 letters, or a couple people that have 12 letters, or a couple people that have 8 letters, right? But then there's going to be some that we don't have any. I bet you there's nobody with 3 letters in their first and last name, right? So this is a really good data set, because there's all different kinds of numbers, some repeating and then some not even there, right? But yet all the numbers are probably going to be less than, say, 30, right? They're not going to be terribly huge. So we can work with that. So, okay, so the first thing I would have had to do is get everybody in order, right, with their index cards, with the numbers on their cards, right? Now, the next thing we would have done, and I'm just going to pretend, let's say we have, I don't want to draw 30 kids. 2, 3, 4, 5, 6, 7. 7 kids is enough, okay? So let's pretend this is our class, and we all have our index cards in our hands showing our numbers, okay? The next thing we do is literally we need to find the middle of the class, of our data set. If each of you represents your data value, right? We need to find the middle. Now that you're all in order, we need to find the middle. Well, how do we find the middle? Well, we literally count from the outer edges and find the middle. Does that make sense? So we start on either end and say, okay, if I work my way towards the center, where is my center? And in this case, this student right here is the center. Do you agree with me? Because there are 3 students to the left of this student, and there are 3 students to the right of this student. That student must be the middle student. So whatever value was on his card or her card, that would be the middle or the center of our data. Does that make sense to everybody? Well, ladies and gentlemen, that person right there would be called our median. Okay? That is another word for a center of a data set. Okay, so there's 2 types of centers of a data set. There's the mean, which is what we learned how to calculate yesterday and the day before. And then there's the median, which we're starting to learn today. Okay, so this median is literally the middle of the data set. But the key thing to the median is that the data set has to be in order. Okay, we have to stand up, and with all of our different numbers, we have to put them in order. And then find the middle person in this example, okay? Now, like I said, I wish we could have done that. It would have been super fun. But I hope with my little explanation there, you understand kind of what we would have done and how that would have helped us. Because in number 2 now, we have our data set from the number of siblings that we just did in our earlier activity, right? We're now going to sort this data from least to greatest. So let's pretend these are cards that people are holding again, right? We're going to put these in order, but we're actually not going to stand up and move around. We're just going to put these numbers in order, okay? So the first one, of course, is going to be 0. I'm going to cross them out as we go. But there's a couple more zeros. So we have to list all the zeros. We can't leave anybody out, right? And then there's a 1. And there's another 1, and there's another 1, okay? And then there's a 2, and another 2. My lead is dying. And then a 7, and then a 10, okay? Now, let's double check. We should still have 10 numbers, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's my numbers, and I have now put them in order from least to greatest, like it said, okay? That is step number 1 when you're finding the median, okay? Step number 1 is put values in order. Okay? The next step is to find the middle. Okay? Now, I call this, ladies and gentlemen, I have a fun name for this. I call this the finger squeeze. Okay? I think you can probably tell why I call it the finger squeeze. You put your fingers on the two end values and then you squeeze towards the middle. Okay? One number at a time until you get to the middle. Okay? So again, I started with 0 and 10, and then I squeezed to 0 and 7. I squeezed to 0 and 2. I squeezed to 1 and 2. And I squeezed to 1 and 1. Now, what did you notice? I actually have two middles this time. See, on this one, I had only one middle, didn't I? But this time, I actually have two middles. And that is okay. We can have two middles, but when that happens, we actually have to find the middle of the two middles. Now, in this case, the middle of 1 and 1 happens to be just 1, right? Does that make sense? The rule is we have to find the mean of the two middles, okay? So I'm going to write that down over here. Find the mean, not the man, the mean of the two middles, if there is one. If there are two middles, then you have to find the mean of the two middles, okay? Now, if I find the mean of this, 1 plus 1 divided by 2 is 1, right? So 1 plus 1 is 2. 2 divided by the two numbers is 1. So my median is 1, because that is literally the middle. And if we look at this, there are 1, 2, 3, 4, 5 data values to the left of 1. And there are 1, 2, 3, 4, 5 data values to the right of 1. Okay? So the median is 1. Okay? So there's the median. Now, one thing I want to point out at this point is, remember when we had the mean before and it wasn't very great? Remember that, how we found the mean of 2.4 and it was far away? Guess what the median was? The median was exactly what we wanted it to be, wasn't it? It was exactly what our estimate was. That really is a center. And do you see how even on 1 there's a middle dot? Oh my goodness, that really is a middle, isn't it? And if we look at this, there are 1, 2, 3, 4, 5 dots to the right of that, and 1, 2, 3, 4, 5 dots to the left of that. So my goodness, 1 really is the median, the middle of our data set. Okay? Very, very good. Let's do another one of these. Part B. In this situation, do you think the median is a good measure of the typical number of siblings for this group? We just barely talked about that, right? According to our graph and according to our math, yeah, that's a great choice, right? So I'm going to say yes. The median is a good center or balancing point, right? Right? It really is. In fact, it matched our estimate. Exactly. Right? So that makes it awesome. Okay? Number 3 now. Here is the dot plot showing the travel time in minutes of Elena's bus ride to school. Am I going to have to... My dog is barking again, like always. Drives me insane, by the way. Maybe he's calming down. Okay, here we go. Here is a dot plot showing the travel times in minutes of Elena's bus rides to school. Find the median travel time. Be prepared to explain your reasoning. Okay, so remember our steps here. Our first step was to put the values in order And then our second step was to find the middle, right? And if needed, we need to find the mean of two middles if that happens, okay? So the first thing we need to do is identify and put in order our data values. Well, the great thing about a dot plot is that they're already in order. 6, 7, 8, 9, 10. They're already in order, so that's easy. But we need to remember that every dot represents a value, a data value, right? So our numbers are 6, 6, 7. There are 3 8s. There are 3 9s. 2 10s, 0 11s, and 1 12. 0 13s, 0 14s. All right. The little boy walking his dog has finally passed the house, and my dog can now stop freaking out. Oh, my goodness gracious. Okay, where were we? Okay, we just put all of our data in order. Okay, that's the first step. We took all of the dots and we wrote down their data values. Now, second step, finger squeeze, right? So let's grab our fingers. We're going to work our way one number at a time until we get to a center. So here we go. Go slowly so that you don't miss any numbers. Okay, now I have 2 middles. And this time my 2 middles are 8 and 9, right? So I need to find the middle of the 2 middles. Now I could do that either in my head. If I know what's exactly in the middle of 8 and 9, I could do that. Or I could find the mean by adding 8 plus 9 and dividing by 2 because there are 2 of them. Well, 8 plus 9 is 17. 17 divided by 2 is 8.5 or 8.5. But I happen to know that exactly in the middle of 8 and 9 is 8.5, right? So either way, we would have gotten the same answer, right? Okay, so that means that the median is 8.5. Okay? Does that make sense to everybody? So the first step, once again, we put all of our data values in order, which was quite handy because they were on a dot plot. Don't forget the repeats because the repeats matter, right? We can't just throw data out of the window, right? And then we finger squeeze till we find a middle. If we get 2 middles, then we have to find the middle of the 2 middles, either by finding the mean mathematically or just by figuring it out mentally to find the middle of those 2 numbers, which in this case happens to be 8.5. Okay, what does the median tell us in this context? Well, if we remember, these are the travel times that Elena's bus ride takes. Okay, and this is our center of our data. So we could say things like a typical bus ride takes about 8.5 minutes to get to school. Okay? That's what that means, right? Because that's what that center of the data means. It's that typical value. It's that center. It's that average, right? So an average bus ride would take about 8.5 minutes to get to school, right? So that's a median, ladies and gentlemen. Keep practicing finding the median. You're going to see this again in your homework tonight in just a few minutes. If you need a little bit more help, make sure you read through this summary. It goes really well through what the median is, gives you another really great example, and walks you through, it actually gives you 2 examples of finding the median, okay? And that, of course, is our glossary term for today. So, if you have questions, you can always look in the glossary for that. We are now ready to dive into our practice problems for the day. You are going to tackle all, I think there are 5 of them, 6 of them. You're going to tackle all 6 math problems today in Lesson 13's homework assignment. So go ahead and flip the page in your workbook to find practice problems for lesson 13. Dive on into that. Do your very, very best to do all those problems on your own. And we will come back in just a few minutes and go over those answers along with you. And as always, I know that you will.
Do your best, because you deserve your best.
All right, I hope you've got your practice problems completed to the best of your ability. Of course, we don't have to be perfect at it yet. We're just practicing, right? So let's go over these quickly and see how well we did. In number 1, it gives us a table that shows the student scores for 10 rounds of a video game, okay? And it asks us to find the median score. Now this one happens to be a multiple choice, okay? And with multiple choice, we're always tempted to not bother with the math, right? But in this case, with this data, is it going to be very easy to identify the median or the middle value? That's really tricky. First of all, I think we should at least put the data in order, because right now you can tell it's not in order. So how are we going to figure out the middle, right? So let's do that first. What's our lowest data value? Let's look through here and find the lowest. It looks like it's 120. So 120 is first, but there's actually 2 of them. Okay, is there any more? Nope, it looks like 130 is next, but there's actually 2 of those. Did you notice? 1 there and 1 there. What would be next? It looks like 140 over here is next, so that's my next line, or my next number. And then it looks like 150 over here is next. And then there's a couple 160s, so we'll do 160, whoops, 160, okay, let's try that again. 160 and 160, cross both of those out, making sure we're not missing anything along the way. And then I have a 170 and a 190. Now, before I go on, I need to double check. Even though I was crossing out as I went, I want to make sure that they're not only in order, but that I have them all. We know that there were 10 of them, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, now I'm confident. Now, at this point, we could probably use our multiple choices to narrow this down. Do I think that 125, which is going to be in here, do you think that's going to be our middle or our center? I don't think so. What about 145? Do you think that's going to be our middle? Ooh, that looks closer. But look at 147. It's right in there as well. Uh-oh. That's really close. And 150. Oh my goodness, those are all really close. So while that was a really good strategy, with what we know right now, I don't think we can narrow it down until we do the math, right? Well, not really the math, the finger squeeze. So let's see what happens when we finger squeeze. We take one number at a time and we squeeze towards the center, okay? Going really carefully. So, okay, we got 2 centers again, 140 and 150. What happens, what's the middle of 140 and 150, do you know? What is exactly halfway between 140 and 150? If you know, then you can just write it down. If you don't know, then we can find the mean by doing 140 plus 150 divided by 2, because there were 2 numbers that we added, okay? Well, 140 plus 150 is 290. Divided by 2. 290 divided by 2. Well, 29 divided by 2 is really close to 30. 30 divided by 2 would be 15. So 29 divided by 2 would be 14.5. So, and with a 0 added on there, that's going to be 145. Oh, look at that. That's one of our choices. Awesome. So I think that B is my median. The answer to number 1 is B. Okay? We just proved it mathematically. Okay? Very, very good. Number 2 now. When he sorts the class's scores on a latest test, the teacher notices that exactly 12 students scored better than Claire and exactly 12 students scored worse than Claire. Does this mean that Claire's score on the test is the median? So she had 12 kids get worse than Claire and 12 kids get better than Claire. Does that mean Claire is the median? That's exactly what it means, isn't it? Claire is literally the middle. If there were 12 worse and 12 better, just like that finger squeeze, Claire would be in the middle, wouldn't she? So the answer to this one is yes. Claire is the middle. Or Claire's score, right? Claire's score is the middle, right? So yes, the answer to number 2 is yes, it is. Okay? Number 3 now. The medians of the following dot plots are 6, 12, 13, and 15, but not in that order. Match each dot plot with its median. Okay. So we need to figure out of these 4 choices, which one matches each of the dot plots. Okay, now, when we're looking at all of these dot plots, there are a couple of ways we could tackle these problems. Just like we did earlier in the lesson, we could list out all these data values, do a finger squeeze, right, and find the middle for each of these. But that seems like a lot of work, right? We already know the 4 answers. We've just got to figure out which one's which. So can we just use the dots themselves and find the middle of the dots? Let's see if we can figure that out. Maybe we can do a finger squeeze on the dots themselves. I think we can. Here's the first dot and the last dot, and then let's work our way towards the middle. I'm going to go top to bottom each time there's a stack. So again, I wish I had, maybe I'll grab another pencil. See if I have another pencil here, because that'll be easier to point with. See how ambidextrous I am with 2 pencils. All right, let's see how I can do here. Wow, that left hand doesn't want to do it. Okay, here we go. So here's our 2 dots, first and last. And then we're going to go to the next dot. Here they are. And then to the next dot. And then to the next dot. Ooh, look at that. And then look at this. We have 2 middles. But they both happen to be at 6. Right? Let's double check that. There's 1, 2, 3, 4 dots on that side and 1, 2, 3, 4 dots on that side. Look at that. 6 is the middle. Was that one of our choices? Yes, it was. So dot plot number 1's median is 6. See how we can do that and not even have to do any of the listing out of the numbers? That's pretty great. All right, let's move on to dot plot number 2 now. I had to erase, and I guess I erased some of my dots. Okay, so here we go. With dot plot number 2, we're going to do the exact same thing. We're going to finger squeeze with our pencils the dots. So here we go. We're going to start on the left-hand side, start on the right-hand side, and squeeze towards the middle. We've got 1 left, 1 right, 1 left, 1 right, 1 left, 1 right, 1 left, 1 right. Look at that. It's right there. That dot right there is our center. Let's double check. There's 1, 2, let's see, which way does that one count? Was there only 1 middle or was there 2 middles? 1 and 1, 1 and 1, 1 and 1, 1 and 1. Oh, there's 2 middles. So I did it wrong. There's 2 middles. Okay? So 2 middles, which means the median is actually halfway in between both of those, right? So there's 1, 2, 3, 4, 5 on this side and 1, 2, 3, 4, 5 on this side, right? You have to remember where you counted that top one, right? Okay, so there's 5 on each side, so my middle is right here in between 14 and 16, which happens to be 15 is my median because both of those dots were both 15, so that was easy, right? Awesome. Moving on to dot plot number 3 now. We're going to do it the exact same way. Let's finger squeeze these dots, starting on the left and then the right. Left first. Here we go. 1, right. left, right, left, right, left, right. Okay, we ended on 2 dots once again, but they're different numbers this time. This time, my left number is 11. So my left number was 11 and my right number was 13. So what is halfway in between 11 and 13? 12. Look at that. 12 is the middle or the median of this data set. Let's double check that. On the left side of 12, there's 1, 2, 3, 4, 5 dots. On the right-hand side of 12, there's 1, 2, 3, 4, 5 dots. So yes, we can be confident that the median of dot plot number 3 is in fact 12. Okay? Which by process of elimination, I bet we can guess what the last median is going to be, right? But we're going to calculate it just to be sure and make sure we didn't make any mistakes, because we all know Miss Hatch makes mistakes. So let's do this. Here we go. Left dot, right dot, left dot, right dot, left dot, right dot, left dot, right dot, left dot, right dot. Look at that. We have 2 middles once again. These 2 middles belong to what number? Well, halfway between 12 and 14 would be 13. So yes, we were right. 13 is the median for dot plot number 4. Okay? Very, very good. Now, we are now ready to go on to number 4 in our practice problems for today. So let's dive into this. I don't have a whole lot of room at the bottom of this page, but that's okay. We'll just kind of use this space that we have up here. In fact, I was trying this out earlier. You can kind of see my work. I tried to erase it, but you can kind of see my work up there. But that's okay. We have plenty of room to work. It says, invent a data set with 5 numbers that has a mean of 10 and a median of 12. Okay? Now, the first thing I want to look at is that median of 12. We know now that the median is the middle. So if I have 5 numbers, I know that my middle number needs to be 12. Does that make sense? And when I put these numbers in order, that middle number needs to be 12, right? Now, when we think about the mean being 10, we need to keep that in mind, right, as we're figuring out what these other numbers can be, right? Now, if the mean is 10, that means when I add these 5 numbers, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and then divide by 5, my answer should be 10, right? That's how we find the mean. And if my middle number is 12, I'm going to have to keep this in mind as I'm guessing some numbers, okay? But let's not make this too hard on ourselves. These have to be in order, right, for 12 to be the middle. So let's just go down 1. How about just 11? And then how about just up 1 to 13, right? Now, what is my sum so far? Because remember, if I put an 11 here and a 13 here, I have to eventually add up to something that when I divide it by 5, that equals 10. Well, what divided by 5 equals 10? What is this going to end up being? What divided by 5 equals 10? Well, that's 50, right? 50 divided by 5 equals 10. So I need to add up to 50. Let's see where I am so far. 11 plus 12 is 23. 23 plus 13 is 36, right? So 36 is 14 away from 50. So these 2 numbers need to add up to 14. Okay? Now I could either do 14 and 0, because I need a number bigger than 13. The only option would be 14. So I could do 14 and 0, or I could do 13 again, because it's okay that they're the same. And then I could put a 1 there, because 13 plus 1 is 14. Which one do you like better, 14 and 0 or 13 and 1? Those are basically our only choices, right? Let's just leave it at 13 and 1. Let's double check. 1 plus 11 is 12. 12 plus 12 is 24. 24 plus 13 is 37. 37 plus 13 is in fact 50. 50 divided by 5 is in fact 10. So I think I can fill this out. Those are my 5 numbers. Now, did it have to be those 5 numbers? No. Okay? It does not have to be those 5 numbers. But the process we went through to find those 5, you can slightly alter, right? And find different numbers that would work. The sum of 50 does have to be true, right? Because the mean does have to be 10. And 12 does need to be the middle number. But other than that, you could alter these slightly. Like this could be a 12 and this could be a 12. And this could be a 13 and a 1. That would still add up, wouldn't it? Because I took one away from here but added it here. So then anyway, there's lots of different possibilities there for number 4. So just if you didn't get this exact answer, don't think you absolutely got it wrong. Just make sure that your 5 numbers add up to 50 and that the middle one is 12. If you did that, then you got that one absolutely correct. Okay? Very, very good. Let's move on to number 5. On number 5, it says 10 6th grade students reported the hours of sleep they got on nights before a school day. Their responses are recorded in the dot plot. Okay, so here's our dot plot for the hours of sleep they got. Looking at the dot plot, Lynn estimated the mean number of hours, so the mean, okay, number of hours of sleep, to be 8.5. So Lynn's guess was 8.5. Noah's estimate was 7.5. And Diego's estimate was 6.5. And we need to figure out which estimate was best. Okay, so let's mark these 3 with our little triangles and see which one we think looks the best. Lynn says 8.5. Well, 8.5 is exactly halfway between 8 and 9. Right? So that's where Lynn says. So I'm going to label that with a Lynn, L. Noah, what do we think about Lynn? Do we think that's a good center? Well, to the right of Lynn's guess, there's only 2 dots. And to the left of Lynn's guess, there's a lot more than 2 dots. I don't think Lynn is right. What do you think? Let's see about Noah. Noah estimated 7.5. So Noah's guess is down here halfway between 7 and 8. I'm going to erase Lynn's guess and take a look at Noah's guess now. Well, Noah's guess looks better to me. Let's count the dots. On the left of Noah, we have 1, 2, 3, 4, 5 dots. And to the right of Noah, we have 1, 2, 3, 4, 5 dots. Ooh, that's looking really positive, right? Let's just double check Diego's guess to make sure we don't agree with it more. Let's try 6.5. 6.5 is halfway between 6 and 7. Oh, here we go, Diego. Do we think that's going to be any good? There's only 2 dots to the left of Diego's and like 8 to the right of Diego's. Nope, I don't think Diego is right. I think Noah is the best answer here. So which estimate is best? Noah's is best, right? And we didn't even have to do any math, but we know that that mean should be the middle, right? Now, wait a second. I was thinking median, wasn't I? Median, we know, is the middle. Maybe we should double check that mathematically and make sure that that is the best mean. Let's see here. If I were to find the mean of these numbers, I would have to do 5 plus 6 plus 7 plus 7 plus 7 plus 8 plus 8 plus 8 plus 9 plus 9, right? So let's add those all up. Oh, and then we're going to have to divide by how many numbers there are. 10. I think there's 10. Yep, 10. Now, if you've got a calculator, like I mentioned yesterday, you're welcome to use calculators from here on out. So if you want to use a calculator on this, you're more than welcome to. I'm going to see if I can't do this in my head. Let's see how well I do. I got 9 plus 9 is 18. 18 plus 8 is 26. Plus 8 is 34. Plus 8 is 42. Plus 7 is 49. Plus 7 is 58. Yep, 58. Right? Plus 7 is 65. 65, yep. 71, 76. Uh-oh, am I off? 7.6 is not an off. I think it's 75. I think I'm just off by 1. 18, 27, 35, 43, 50, 57. Oh, I was off. 64, 75. Yep, 75 divided by 10 is 7.5. Look at that. That little balance trick actually did work. Mathematically, 7.5, Noah's guess, really is the best. So that's 2 really great ways of finding these estimates. Very, very good. Noah's is the best mean as a center, as a middle, right? And mathematically. Right? So we actually showed it in 2 different ways for number 5. Okay? Number 6, in a study of wild bears, researchers measured the weights in pounds of 143 wild bears that ranged in age from newborn to 15 years old. The data were used to make this histogram. Okay, now I know this histogram is kind of hard to see, but I think it's okay. What can you say about the heaviest bear in this group? Well, if the axis down here is the weight in pounds, then the heaviest bear is over here. We don't know its exact weight because remember, these are ranges of weights. But for part A, I'm just going to put part A down here. We know that the largest bear weighs somewhere between 500 and 550 pounds. And that's the best we can do because we don't actually know exactly where in that range that bear's weight is, do we? Okay, part B. What is the typical weight for the bears in this group? Well, again, the typical weight is either the mean or the median or the center, right? So where do we think the center of this data is? Well, I'm going to write down these frequencies here because that's going to help us figure out how many data dots or whatever we would have had, right? So this is about 6 because it's slightly above 5. This is really just an estimate because we don't actually have these datas. That's going to be like 17. I think that's right at 40. This is probably at about 28. Maybe 15 there. About 8 there. And this really is an estimate. I'm just eyeballing these, so I might not be exactly right. Sure. I don't know if those are right. And those are really teeny writing too. So really the only reason I wrote those all out is because I need to find the middle. So I kind of need to know how many are on one side and how many are on the other. Okay. I'm really tempted to say that the middle is going to be right up here in our biggest bar. But we need to realize there are a lot of things happening on this side, right? So maybe our middle is more like in the middle of this bar. I'm thinking it is. I'm thinking it's more like right here at about 150. What do you guys think? If I add up those numbers, what do we think? Maybe it's closer to 200. This is 23, 63, 70, 80. This is going to be 10, 20, 30, 40, 50, 60. Yeah, see, I think that's too many on this side. I think it's going to be somewhere closer to 200, actually. What do you think? You know, this is an estimate, right? So really, as long as it makes sense, I really can't mark this problem wrong, can I? I'm going to see about, I don't know, somewhere between 150 and 200, but I'm going to say about 200 pounds is the typical weight for this bear, okay? Do more than half of the bears in this group weigh less than 250 pounds? Well, this one I think we can figure out. If 250 are more than half of them less than that, I think we can safely say, because these are the biggest bars, right, that is definitely more than half. There's not as many on this side as there are on that side. So I would definitely say yes for that one, right? And then the last one, if weight is related to age, with older bears tending to have greater body weights, would you say that there are more old bears or more young bears in this group? Well, if the smaller the weight, the younger the age, wouldn't that mean that these are all younger? All these big numbers would have to be more younger bears, wouldn't they? Because the bigger the bear, the older they are, and there's not very many older bears, right? So I'm going to say more younger bears. Because there are more, I always do that with my H's, there are more lighter bears, right? So because there's more lighter weight bears, there must be more younger bears. Okay, so there you go. There's the end of number 6. We are now done with our practice problems for lesson 13. How did you do? I hope you feel confident and ready to dive into your Check Your Understanding quiz, because that's what's coming up next. Don't forget to do your very, very best on that. One little hint, we've been rushing a little bit, I think. Slow down, read the questions carefully. I think a lot of us are making mistakes because we're not reading carefully and looking at the graphs carefully, the dot plots or the histograms or whatever they may be. We need to make sure we take the time to look carefully and read carefully. A lot of silly mistakes these days, so make sure you're being careful. All right, I know you'll do your best and slow down, right? Because as always,
do your best because you deserve your best.